When solving a related rates question, there are 5 steps you should follow. Step 1 is to draw yourself a diagram. Step 2 is to label that diagram with the variables and the constants. Step 3, you need to write down an equation linking the variables, and that equation can come from things like Pythagoras, similarity, or your basic trig. Step 4, you'd use implicit differentiation to differentiate with respect to time. And step 5, you would substitute values for your particular case in order to solve the problem. Reminders down here: if the y by t is greater than 0, then as y increases, so does t. To remember that, just think of the y by dx. If that is positive, that means you have a positive slope, and you know that the line is increasing, and you know that as x increases, and so does y. If the y by t is negative, once again think of a negative slope. As one increases, the other decreases. Now the solution to question 1 from 6F I've got here for you. We have the equation ab cubed equals 40. We need to differentiate that with respect to time. I would encourage you to write down something of this form. Differentiating using the product rule, differentiate a becomes the a by the t, and the b cubed is still part of the product. Then the a, you leave that alone. Differentiate the b cubed, we get 3b squared with the b by the t. And differentiate a constant, you end up with 0. Now in our particular case, we are told that a equals 5. Now if a equals 5, you plug in a equals 5 here, it's 5 times by 8 makes 40. So if b cubed equals 8, that will give us b equals 2. We also know that the rate of change of b is a positive 1 because it's increasing. So the b by the t equals 1. Right, and now we substitute those values into our equation here. So the a by the t we don't know, but b cubed we know is equal to 2 cubed, 8, and a times by 3b squared, etc. We make our substitutions. We can then rearrange to get the a by the t, simplify that, and always finish off in words. If you've got a negative rate, then that means that we have a decreasing rate. So a is decreasing at 7.5 units per second. Notice you don't write a is decreasing at negative 7.5. You've already made the point that it's a negative by saying decreasing. You wouldn't put a negative on the 7.5. Now the solution for question 6. We have our formula once again provided to us. So PV to the power 1.5 equals 400. So we begin with that equation, and we can change 1.5 into 3 on 2. Now differentiate with respect to t. Notice I've abbreviated that whole line, but I still have written down what I'm differentiating with respect to. I differentiate p, becomes the b by the t, and that v will remain part of the product. Now add that to, leave the p alone, differentiate the v, and we end up with that as the rest of the equation. Now in our particular case, we are told that the rate of change is of pressure is 3, which we have over here. That's also increasing, so it's positive. We want to work out what's happening when p equals 50. Now if p equals 50, we should be able to work out what v is at that time. So we have 50 for p, divide 50 into 400, we get 8. So v to the power of 3 on 2 equals 8. And if we solve that, to get v equals 4. Sub these values into our differential equation here, and then rearrange to get the v by the t by itself, and finish off by writing in words. Once again, we have a negative rate, and therefore the volume is decreasing, and converted that fraction into a decimal. Once again, decreasing, we don't put the negative on this number. Okay, we've already made that fact known by talking about decreasing rates.